Hey everyone, welcome back to Next Gen STEM Animation. In Unit 1, we talked about what animation is and the basic types you'll see, like 2D and 3D. Today, we're going to focus on something simple but super important, how objects move. To start, however, we're using the classic animation test subject, a ball. Balls are perfect for learning animation because they're easy to understand. When you learn how a ball moves, you learn timing, spacing, arcs, weight, and even personality. Once you master ball movement, you can animate almost anything. Like as you can see here. If I get a basic mapping of where the ball is going to be moving, I can draw, for example, a hand bending to punch someone. We know the basic motion path, so we can move the hand accordingly. Timing is how long it takes for something to happen. Spacing is how far an object moves between each frame. If the ball has even spacing, it looks slow. If the spacing suddenly becomes wide, the ball looks fast. I'll show 2 examples. A slow drop, where frames are closer together, looks like this. The second example I'll show you is the fast drop. Frames spread farther apart the more the ball moves or falls. Now let's talk about arcs. Almost everything in animation moves in an arc instead of a straight line. Think of a basketball being tossed. It curves up and then curves down because of the gravity. If you animate a ball in a straight stiff line, it looks robotic. Like if I'm throwing a ball to someone and someone animates it, and if it's just straight and stiff, it doesn't look real, right? It doesn't show you the speed, it doesn't show you the weight of the object, etc. Now let's look at if we draw an arc. Compared to a straight line of motion, arcs and arcal movements make things feel natural and look smoother. Next is the most famous animation principle. Squash and stretch makes objects feel alive and gives them weight. When a ball hits the ground, it squashes a little. When it launches back up, it stretches. But you never change the total volume. If the ball gets wider, it also gets shorter. This principle helps you show force and energy. Even simple movements look better with squash and stretch. Alright, finally, let's talk about characters and objects. Small changes in the animation can show different emotions. Let's look at a heavy bowling ball, for example. The bowling ball barely squishes because of its density and weight. However, if we look at a bouncy rubber ball, we can see that it stretches and squishes a lot because it's not very dense compared to the bowling ball. Finally, if we look at a water balloon, we can see that it squashes a lot but barely bounces. You're not just moving a ball when you animate it. You're giving the ball personality with the small changes. Alright, to end this video off, I'm going to animate a ball drop with correct timing, clean spacing, a smooth arc, and squash and stretch on the bounce. Look at this animation. We can see that the ball follows all the principles talked about in this video. It has correct timing, showing the differences in speed between the movement from the throw and the ground and the bounce. It has clean spacing, which shows the squash and stretch. It has a smooth arc as well. Alright, let's think here for a second. Does this really look smooth and natural? No, because it doesn't incorporate any of the principles we just talked about. Thus, it doesn't make it look natural. So it looks stiff, and it has no personality or no emotion to it. So it looks very robotic. Alright, that's Unit 2. Your practice this week is to animate a bouncing ball using timing, spacing, arcs, and squash. Now, I'm not requiring you to do this, but it's really good for the upcoming challenge that you're about to get. The next units will get into more complex movement. Bye, and I'll catch you online.